Hey, today we have Jose Valim as a guest on the Top Shelf, where we're going to be discussing all things Elixir, how he got here, some pretty cool insights into his life and the language. Today's sponsor is CodeRabbit. If you're looking to review some code, you should really check them out. And Boot.dev is the other sponsor. TJ and I both have courses on Boot.dev, and we have a combined promo code BTW. That's boot.dev/BTW. I hope you enjoy this episode.
Hey everybody, it's me, TJ DeVries here, and welcome to Top Shelf. As always, we have my illiterate co-host, the Primogen here.
Hey, I resemble that comment.
And our guest today is Jose Valim, the creator of Elixir. Welcome, Jose.
Hello, thanks for having me.
It's our pleasure. Several years ago, you said Elixir was a finished project, a completed language. My first question is, how does it feel to ever get close to something that is called a completed project? The Primogen and I are completely unaware of this feeling.
Yeah, what is it like?
What does it feel to have lied back that many years ago? So I think what was that? 5 years ago, 6 years ago? There's actually a lot of things to tell you that story, but the things like since the beginning, I always saw Elixir to be like this kind of small language that is extensible. So almost a lot of Elixir is written in terms of itself, because like my perspective was always like, look, at the time when I was working on Elixir, the other like coming up languages was like Go, which is backed by Google, right? And then we had Rust backed by Mozilla at the time, and then Swift came later. And then I'm like, how would I ever be able to compete with those languages, right? So for me, it was always like, I need to have something small, right? That is extensible, that everybody can get it and do whatever they want with it and bring it to different domains. So today I like to say, look, like we have a subset of Elixir that compiles to the GPU, and we didn't have to change the language for that to happen. That's a library. So for me, it was always like, hey, the goal is to be extensible. But like you launch 1.0 and then you get a lot of feedback, things that people request, and a lot of things you can say, look, that can be a library. It doesn't have to be part of the language. But there are things that like, look, that makes sense to be part of the language, which like a type system, which we have been researching now. And that's why I said that I lie, because it may change still. But a lot of it was exactly, no, it should be small and the language should be extensible, which means that the innovation, the next steps of Elixir should really be happening in the community. And that was the message back then, right? Like the work is not on the language itself. The work is on the ecosystem, the community around it. And it has been true for quite some time, and it still has been true today. Like we still didn't make major changes to the language. But of course, if the type system will actually become a thing, then of course that is going to change. And there is just one thing I want to tell, like in this whole story thing here, is that back in 2020, it was like at the beginning of the year, mid of the year, COVID had already started. Like we were in the situation like, oh, Elixir is kind of done. I had talked about it, and I was delegating most of it to like LiveView was announced, and the LiveView team was taking it forward. And then I was thinking like, I think I'm kind of ready to like retire, in the sense, not like stop programming, but it's like, maybe I should just program like, part-time and do whatever the fuck I want with the rest of my time, right? And then by the end of that year, I started both the Elixir machine learning thing with other people, which is like 10-year effort, right? And the type system stuff, we started having discussions. So, like within a year, I was like, maybe I don't have anything extra to do to like, okay, I'll be busy for the next decade. So.
Well,
yeah, I think, I was just going to say, I think that is one of the fun things about programming, particularly on projects as ambitious as Elixir, is just getting to see where things happen next and where they take you. But go ahead, Prime. What were you going to say?
A big thing about, like, I think a lot of people have been talking about these languages that have all kind of been coming out over the last decade. I think that our choice of languages has greatly increased. But one thing that I think a lot of people are saying about languages these days are actually seeing it in production. You know, like Haskell exists in white papers, Rust exists in the minds of its users. And so, like, does Elixir have great success stories about being in production?
Yeah, there are definitely. So if you go like to the web, it depends what you mean by great success stories, right? But I think probably in terms of scale, the biggest one you're going to find is the Discord one, right? So the messaging on Discord goes through Elixir, and that's a really big case. And then from there, you get big corporations just using it for like boring cases or not necessarily exciting cases. So we know there are a lot of companies within like the SAP 500 that use Elixir, right? But they're just using for like, for building internal systems, right? And something that is very funny that whenever that comes up in discussion, somebody's like, oh, that's not important. But it's like, well, how do you think that Python gets to where Python is if it's not because you have like the SAP 500 using it for boring stuff as well, right? So on the website, we have like cases from Discord, Mozilla, Heroku was using it for a while. I'm not going to remember everything. We try to, in the website, the cases to balance between, this is like really interesting and between like, this is really popular, and try to find a balance between both. So there's like, one of the cases that I like, there is the X-Plane, which is a flight simulator kind of game, and they introduce like multiplayer. They introduce like a multiplayer mode, and that's running on Elixir, right? And it's not the most popular game, like maybe getting, I don't know, whatever people play these days is very popular. Probably still Fortnite. If they were using Elixir, it would probably be like more interesting and exciting. But I feel like, oh yeah, somebody's building like distributed server. And what is really cool about that case in particular is that they were all new to Elixir. Like they're like, we want to do multiplayer, okay? And we have like these 3 or 4 different languages. And they picked Elixir without knowing it. They learned it and they delivered the thing, and it worked. And that for me in itself is like, it's not like boom case, but it's like, for me, that's a great success, right? So, yeah.
So can we just rewind just one quick second about the Discord one? So I was under the impression that Discord uses Rust on the back end. Rust is a success story, but I didn't realize they used Elixir. Which parts did you say they used Elixir for?
So the messaging is in Elixir, and they sometimes my camera get out of focus. Let me know, and I can reset it. But for the messaging, so I believe like they have a Python API, and the whole messaging things they use Elixir, and they have like even a recent blog post about like the blog post where they say like they reduce the traffic was by like changing the compression, and the compression was like an Elixir library, and that thing, and I know their Elixir backend for certain things is going to have like Rust bindings. So for example, I'm going to conjure some numbers here, but imagine like at some point they had like 1 million people in one room. I don't know if that's possible, but they had like 1 million people, and then they're like, look, for us to manage like 1 million people, where people are coming and leaving all the time because they have 1 million people, they need a specific data structure. So they went and implemented like this very efficient SAT in Rust, but Elixir is the one doing messaging, communicating with the SAT, and so on. Yeah. And then, go ahead. Sorry.
No, I was going to say it's interesting too how Elixir can sort of be orchestrating a bunch of these different things, even if you want to replace like one part for some high performance aspect that maybe Elixir isn't the perfect language to do. It's pretty interesting to see.
Hey Prime.
Yeah?
Have you heard of today's sponsor, CodeRabbit?
Let me guess, it's an AI code review tool that people actually use and is good.
Yeah, that's correct.
Let me guess, CodeRabbit's being used in over 1 million repositories and has reviewed more than 5 million pull requests?
Okay, 2 in a row, that's a little weird.
Let me guess, it's not just AI, but there's tools built on top such as AST, grep, linters, and more.
Are you Steph Curry? Because you're hitting every shot.
Let me guess, it works on every major platform. It has enterprise features such as SOC 2, and it has pluggable LLMs.
Okay, are you that Turkish guy, Mr. Shooter? If you know so much about CodeRabbit, what should our listeners do?
They should click the link in the description and install CodeRabbit in their open source repos for free. But seriously, check out CodeRabbit. It's actually really good.
In the description.
One of the things I was interested about, sort of more on the history side of Elixir itself, is how did we get to Elixir from Ruby? That's what I want to know, how we started with Ruby and ended at Elixir.
Yeah, so I was part of it was a long journey. It was not like there is like that XKCD is like, oh, I have a problem, and then like, oh, I use rejexes and I have two problems. Like for me, like there's a 10 times worse version of that. It's like I have a problem. It's like you create a new programming language, then now you have like 1,000 problems, right? So it was a long journey, and but to me, it started with concurrency, right? So this was Elixir, like the first commit was about like 2011, but I was on the Rails team before, and at the time we started to hear a lot about concurrency, right? And it's like, oh, the future you're going to have multiple cores, right? And there's a very famous paper called "The Free Lunch is Over." Because before it was very convenient to be a developer. You did nothing for 2 years. The hardware got twice faster and everything ran twice faster. It was pretty great, right? That's the free lunch. It was over. And today I say like your watch like has 4 cores, right? So back then we were starting to talk a lot about it. And one of the the pivotal moments in all of this was that I was in the Rails team and somebody did a bug report. And the bug report was kind of like this. Look, we have a Rails application running in production, and when there is a spike, and we have enabled like threading in this Rails application, and when there's a spike in production and auto scale kicks in, we start a new app, and that app fails to boot. That was the bug report, right? And the reason why the app was failing to boot is because when Rails is booting, like setting up the cache, as it was setting up stuff, multiple requests were coming at the same time and triggering a race condition that would make it fail, right? So when you get a bug report like this, you're like, and the bug report was really well done, but it's like, look, how am I even going to fix this bug, right? Like, first, how am I going to reproduce it, right? Because it's when out of scale kicks in, right? So that's not going to be easy, right? And then like, how I'm going to reproduce it. I'm going to make sure that the bug fix actually works. I'm going to write regression tests. So I was like, look, if concurrency is going to be the future, I don't think we have like the proper tools. So I started like, I want to learn more about concurrency. I don't have like a computer science background. So it's like, I want to learn more about concurrency. And then in this journey to learn more, I eventually found the Erlang virtual machine, which I absolutely fell in love with. Because like, if we go back 10 years, like the languages that I was talking about, like Go, Clojure, right, Swift later on, all those languages that were coming out at the time, they're all talking about concurrency. That's all they were talking about. Oh, we have new abstractions for concurrency, right? It was the problem in everybody's head, right? And then when I got to learn Erlang, they're like, yes, we do have concurrency, but not only we solved concurrency, we also solved the next problem. What is the next problem? Well, the goal of concurrency is to use all the resources in my machine as efficiently as possible. That's what we want to do, right? We want to use all the cores with the memory very efficiently, right? But when you're doing something that does not fit on a single machine anymore, right? You need another machine, right? Or maybe you want 2 machines for resilience purposes, right? So now you need to talk about distribution. So Erlang, they're like, not only we solved concurrency, but we also solved the next problem, which is distribution. By the way, we solved this 3 decades ago, and it's the same abstraction that we use both for concurrency and distribution. It's the same abstraction. So I was like, like, this is amazing. It was like, I was, as soon as I read it, I was reading like books and the 7 languages, 7 weeks book. As soon as I read it, I was like, this is it. This is what I want to use. This is where I want to write like the next decade of my my software, my programs, whatever. That's what I want to do. And then of course there was like the whole, and then the way that I like to say is that I loved everything that I saw in Erlang, but I hated some of the things that I felt was missing. And then I said, okay, let me try to. So like Elixir actually started as a project for me to learn more about Erlang as well. I was like, okay, I don't know about how programming languages work. I want to learn more about Erlang. Let me try writing one. And then eventually I was like, wait, I think there's something here. I think like the things that I'm looking in Erlang that I feel are missing, it may also be missing for other people. And then after some time, a lot of like false starts, eventually we get into the Elixir that we have today.
So Ryan Winchester absolutely loves Elixir. I'm sure you've probably heard his name floating around on Twitter. He's always doing that, and he always says that I love Go's concurrency. But if you could give me a good pitch as to why I should love even more the Elixir concurrency model, how would you sell me, a lover of the Go flavored concurrency?
So that's he actually told me about this. He's like you're a big fan of the Go concurrency mod, and that would be a good place to go. But I was a fool and did not prepare. So let's do it live, right? So I think like they are very similar in the sense that they are green threads, right? So you can spawn like millions of those things, right? And they're going to have some, I believe coroutines, they also have their own stack that is separated. Is that correct?
Mm-hmm.
Right? So there are a lot of similarities. They are really close models. The communication is a little bit different, right? So in Go, you're going to use channels for communication. And then the Erlang model is based around actors, right? So you're not putting things in a channel and you're going to expect somebody to pick up. You're rather sending a message to something in particular, right? And we can go like very meta about this. There are like papers that prove that they are the same, right? But one of the benefits of the Erlang model, and you're sending a message to somebody, is that the Erlang VM abstracts to whom you're sending a message in the way it doesn't matter if it's in the same machine or if it's another process in the cluster, right? And that's a lot of what facilitates the building distributed software in Elixir, right? And it's actually beautiful because most of the time you want to make things distributed. It's just a matter of saying, oh, I just want to spawn that thing on the other node, because the whole communication for concurrency distribution is the same. So I would say like that's one of the big differences. And it's also fantastic because if you want to write like distributed software, right? It's like, and you don't have like 3 machines to test. You can totally write the thing first on one machine, develop, test it, and then you're like, I want to make it distributed. You make the next step and make sure that everything works on those scenarios as well, right? So like we are doing things like with machine learning, and we have like to track like how data is allocated on GPUs across clusters. And I wrote like a distributed GC algorithm in a weekend, right? I don't think it's like it's just because of the abstraction. So that's one of the big differences. And the other thing is that the process in the Erlang virtual machine, they are fully isolated from each other. There is no shared state. And this is essential for writing concurrent, resilient software. Because if 2 processes share a state, right, or 2 routines, they share a state, and something goes wrong, right, you don't know that when that thing went wrong, you actually don't know if it because like if it let the state corrupted, right? Like maybe there was something wrong, the state was corrupted, and now anything that is collaborating on that state is kind of like game over, right? Because you don't know what caused the issue, right? So in Erlang, the process model, it's based, all those things are isolated. The message passing, there's the downside that you are copying, right? When you send messages, there are a bunch of optimizations, but usually you are copying the data when you send between processes, which by the way, is what is going to happen anyway if you have to do distribution, right? So the whole model makes sense. But on the same machine, there may be some optimizations, but you should think that the data is being copied. But if something goes wrong, you're like, okay, that thing went wrong. and the rest of the system can react independent of that and say like, okay, I'm going to restart that thing, right? So I think that's are the main differences you get from the Erlang model. It's really the Erlang model, right? I did not come up with any of this. You are getting the fault tolerance aspect and the distribution aspect as well.
Yeah, I think
I don't. Yeah. Tell me, Prime. What is that?
Yeah,
How
tell him.
how was I? Give me 0 to 10. How convincing was that? Be honest.
Oh,
Or it's like not where you want to go.
well, the thing is that when it comes to using Go and a lot of its concurrency stuff, it feels like it's like 98% a good idea, and then 2% huge, just giant foot guns, right? So if you have a couple things that need to go off and do something to come back, you have to have wait groups. You have to be able to kind of like manage your side of concurrency. If you have something, you have this really difficult time of mixing, doing a concurrent like activity such as a read and being able to communicate out what is happening with that read. A good example of that is if you want to read a file and then get in lines that are coming in, and say that file is a TCP connection, whatever it is, right? Some sort of reader that exists. There's not really like a super convenient way of doing that. You're like, oh, I want to be able to read, but maybe I want to wait 5 seconds, and if it doesn't work out, I then want to be done. Or maybe I have a context that when I'm done, it stops reading. Well, it turns out the read with timeout might exist. I can't remember, but the read with context does not exist. And so you're just constantly like battling and setting up all of your own ways to handle concurrency. So it's kind of like Go gives you all the pieces to do great concurrency, and they're all really good, except for you have to do your own mutacies, if you will, all your own mutexes. You have to do all of your own wait groups. You have to do all of your own error handling that ensures that an error that you're receiving isn't actually an error, but it's just an end of stream. You have to set up everything yourself. And so when I hear all this stuff, it sounds like it's just a little bit more hardened or user-friendly version of the exact same thing in some sense, where it's like you still have this communication channel that you can communicate out on. Actor model seems to be a superior version of using channels because channels are a bit more, there's just so many rules around them and getting things wrong, whereas it's just like, it does feel really nice. And so I am very curious about using it because in theoretics, it seems like they're very similar, but in practical, like boots on the ground, it seems like it's going to be a lot easier to do the same things.
Yeah, I would say that we tend to be higher level than that. So in the sense that, so internally, like a lot of the like when you do I/O in Erlang, it's going to map internally to sending messages. But usually when we are thinking about those things, we are thinking at a way higher level usually. So I think that would be like you described like the problems that you had with Go, for example. I would not have those problems, not because they do not exist, they may exist, but usually we are just solving everything at a higher level. And when it comes to I/O, I'm using the messages that the Erlang VM is going to give to me. It has been abstracted. And then it comes with the downside. Like if you want to really go down to the I/O and fine tune that, you're not going to have the options. But yeah, I am at a higher level and expressing problems at a higher level, right? Which I think it's kind of where they wanted to go with the design of the Erlang virtual machine, right? Like if you look, I think, correct me if I'm wrong, but Go is going to lend itself more to systems programming, right? Where the Erlang virtual machine is more about network programming, right? And having the network abstractions figured out, because what I want to do is to implement the higher level protocols that are going to be running on top of the I/O.
Yeah, I think one of Go's biggest mistake was actually trying to convince people it was a systems level. It really is more of a network level, but it's just a network level that's the convenience of systems level, if you will. So it allows maybe perhaps more performant abstractions that allow for the larger scale, like putting Google in perspective, where they have, anything they do is, oh, we're going to do that 10 billion times in the next hour. So it's like maybe they just had a different kind of motivation for why they wrote things, which leads to less convenient abstractions. But I love everything you've said. Everything you've said just makes me feel very happy on the inside, and it just makes me want to take more time with this Elixir arc that's slowly developing in my heart.
I think he's underselling too. Like in Go, you really have to be worried about like lock contention and other kinds of problems because of the shared state. Right, it's not a completely separate process when you do a go func, right? They're gonna it is possible to share state. It is sometimes encouraged to share state, right? So it's like
Closures exist.
okay, so
You just
closures exist. It is not immutable in the same way that that Elixir is, right? And so I think, you know, I'm not a professional Elixir dev, but Ryan did give me at least the level of junior Elixir engineer after some of my last projects where I was writing Elixir. So I do have some experience at least. I've made a few gen servers, so I've got, a few of those in my pocket. But I never have to think about like locking or doing a bunch of these other things because I just make a process that handles that and it replies to messages, right? So there's like a really different it's just a really different mindset from the kind of like mix I feel of sort of more imperative style like concurrency that I get inside of Go versus this like actor model, which is all about I just send messages and it could be this computer, another computer, it could be this computer 5 minutes from now. It just doesn't matter. It's just like eventually going to happen somewhere else. And that like clear line really helps, I think, to not end up in this situation with deadlocks and mutexes everywhere and everywhere else. I don't like, are other people writing mutexes in Elixir and I just don't know because I haven't gotten advanced enough, or like this just never happens, right? It just never happens.
Yeah, it's very unlikely that you are going to a place where, like, I mean, we don't have mutexes in the standard library.
Mhm.
And there are going to be like some locking and concurrency patterns, but again, like the really cool thing, so like the Erlang VM has a module called global, right? And that's like one of the nice things is like, oh, what is global for the Erlang VM? It's actually a whole cluster, right? You usually think it's like, oh, it's the operating system process. No, they have like a module called global that has some like locking primitives, but it's like across the whole cluster because the whole thing distributed as well, right? So again, like we are usually sitting at a higher level. But I do have a follow-up question to which is like, how frequently, like we would just say like a general like Go programmer would be actually writing Go routines, listening on a channel, and this kind of stuff? So like Prime, like were you like chasing those sort of problems to solve, or is it something that we're actually doing all the time?
So I've been really into simulation testing. So your problem about the whole startup and being able to tell how something has gone wrong due to this like really weird kind of crazy edge case that only happens every now and then. I've been really into simulation testing lately, and I'm building kind of a concurrent server item. And during it, I've found a bunch of problems, and they've all almost exclusively been around just some really tiny oopsie daisies. Like a good one last night is that I'm adding and removing connections at the same time, just spamming, adding and removing. Well, I take a like kind of a picture of what's available. So the connections that are already connected, I only want to remove from there, and then I only want to add new ones here and kind of do this like little round. So I don't accidentally try to remove a connection that hasn't even made its full cycle through connecting. And by doing that, I had this race condition in my two Go routines where when I'd call length, I had to use a mutex. And so the first one would actually slip in and get the mutex first and start writing and start adding positions into the list, whereas the next one was waiting. And then finally, when it was notified, it would then get into length that was larger, and I'd still accidentally, 1 out of every 100 times I did 10,000 connections, I would get this one time where I tried to remove a connection because the random number generator perfectly landed into the extra one connection that was added. And so it's like that kind of stuff does happen. Just, it feels like way more frequently than I thought it was going to happen. Okay. And it's all surrounding around mutacies, if you will.
Yeah, the reason I'm asking is because like this is one, I think I'm going to use the word friction, but there's probably a better word, like one of the frictions in the Elixir community, because like like we're having this conversation, we are talking about like the concurrency model, and we are talking about gen servers and things being distributed, and that like gets people excited, right? But the thing is that most of the problems where you're going to use these abstractions, they have been solved. Right. So I like to use, for example, a database connection pool. Like those things, they are great primitives for like build a database connection pool, because if something goes wrong, you want the pool to be able to spawn a new connection back in place, right? You want to be able to do all those things, but they have been solved, right? So for a while, we had like people gatekeeping the community, like, oh, you cannot really say you are an Elixir developer if you have not written a June server, right? But I actually think it's a good thing. It's like, it's my job and the job of like framework authors for you to not have to worry about the June server and like the concurrency things, because we are going to Phoenix, for example, the web framework is going to provide all the abstractions for you. And then maybe sometime we are going to use, we have this thing called task, which is like a bunch of conveniences for doing like concurrent processing. If you have to go like to different URLs, get data and this kind of stuff, right? And that's all baked in the standard library. So in your day-to-day, you're like, even though I was attracted to the abstractions, in your day-to-day, you're not actually writing a lot of the low-level code. You're using the existing APIs, the existing pools, the existing HTTP clients. A lot of those problems have been solved for you.
So you kind of just said something that's really up my alley, I would say, something that I'm fairly passionate about, which is reinventing the wheel for learning's sake. Do you recommend people actually do this sooner in their journey than later? Because you're saying, well, hey, it's really great that they haven't implemented some of these kind of lower level things. Hey, library authors, whatever authors should use these, but not regular. Isn't it very beneficial also to push people in non-like standard path, like extracurricular paths, to learn more of these deep concepts as soon as possible? Or sooner than later?
So it's really tricky for me, right? Because like I've been doing this for like almost 20 years at this point. And like, even so, like my brother has been transitioning into programming. And like there's a lot to learn, it's like he's doing web, like I mean, when I started, nobody cared about source control, and that's a whole other conversation. But like, there is Git, JavaScript, CSS, HTML, and then you have to learn Elixir, right? And then you have to learn SQL. So it's like, like should we push those things? I think in a way, yes, but I think it should ultimately be like the person's choice, and if that's the thing they want to really specialize on. So like I like concurrency, right? For some reason I like it. Like I like distribution, right? So it provides me with a lot, like the Erlang virtual machine provides me with a lot of things for me to be excited and geek out, right? And go really deep, right? But I wouldn't say that people need to do that. I think for us to, so often what I compare like Jump server with threads. For me, like it's not the same, right? Like you wouldn't compare Go routines with threads, but for me, they're like about the same range. Like there is the other communities, like the Java people, they're not like, oh, you should go for the threading library, right? And learn about mutaxes. You're going to have the best time, right? They're not really doing that, right? And I don't think we should do that as well, right? For me, it's at the same level. I think it's actually a huge bonus that we can tell people, like, if you want to learn Jun server, you're going to have a good time, where other languages are going like, oh, if you want to learn our concurrency abstractions, like brace yourself. I think that's like a really good thing, but I wouldn't say that people have to learn it. It's like, if it's there, if you learn it, let's geek out. But if you don't, go for it.
Yeah. Along that line of basically, new programmers experiencing Elixir, trying out Phoenix and LiveView and all of these other things, I'm sort of interested from a higher level perspective as a language designer. What are features that are in Elixir that you feel really proud of, that make like the onboarding for people easy and exciting, that lets them be productive quickly? Are there a few things where you're like, oh, I feel like we really nailed X, right? Like, what is X in that scenario?
Oh yeah, that's a really good question. And so I don't think I have an answer per se. I can tell you what I did, right? So for me, it was always like, look, Elixir is a functional programming language. It's a concurrence programming language. It's a distributed programming language, as we are talking about it, and as I have like been historically presenting it. I think, and this is a conversation we can have. I think like there is an argument to be made that we should change how Elixir is presented today based on what we have been talking, and we should swap things around, like make other things the priority there. But that's how you're going to do it. And those are things that, and like people, they're not really learning functional programming at school. Like some university schools they teach, they're not going to do it, right? In general, it's not, they do not have that knowledge, right? And if they learn concurrency, it's going to be a separate concurrency thing than the one we have. And also, and distribution even less likely, but also even less needed. It's really for the library builders, right? So for me, it was always, look, it was always about the tooling, and I think like this is a lesson that Go made really clear for everybody. I like to say like Go, like tooling being first class is something that people have been talking about it, but Go was like, has to be part of the language, should not be negotiable. Right. And we picked that up. So really good tooling. I wanted to say, look, I'm going to give a presentation on Elixir. When I was starting out, I would go to events, and I want every person, after they leave the presentation, to be able to install something, run a command, get a project working, right? Go to the documentation, right? And find what they need, right? So we put so much work on the documentation, like at every level. So I guess if I had to answer your question, I would say like documentation is the thing. Like if you go like the amount of features that we have in our documentation tooling, we wrote a blog post recently, but like it comes with the built-in search. Like we support actual cheat sheets in the documentation. We defined a format called like cheat MD, which is a format of Markdown that becomes a cheat sheet. So because we want to encourage developers to publish cheat sheets and to publish guides. So and API references. So all the kind of things that you want to do with the documentation, we put there in the tooling. It's there out of the box. Anybody can use it. And also no cheating, right? I don't want to have those tools only for the language. Everything that we do should be for the whole ecosystem. So we have this cohesive documentation. The whole ecosystem looks the same, is accessed the same. Like in the language design, we made it so like documentation is easy to write. It's easy to read. We really want to encourage people to do that. You can write doc tests, which is when you write like snippets in your documentation, and the test suite actually guarantee that those snippets are up to date and working. So it was a lot of that. Like, I wanted to make sure it's a learning curve. There is going to be friction, right? And there's going to be natural friction because it's functional programming, because it's concurrency, right? So I have any other possible friction that I can remove, I should remove, right? And that was the rationale behind like trying to make Elixir accessible, right? And there are still things that it's hard. So I gave a lot of positive examples, okay, and about where I think Elixir is great. But there are some problems, which is, so look, if you ask me, so some of the negatives, if you ask me to choose between imperative programming and functional programming, I'm going to pick functional programming. Okay, and it's not about like functional programming means, I'm going to rephrase that. I'm not going to pick functional programming. I'm going to pick immutability. Okay, forget functional programming. Not important. Not relevant. Right. It's about immutability. Right. It's about like when you call a function and then you pass an argument and then you're like, wait, did that function change the argument that I passed? And you're not sure, and now you're like, so when I go back to write in a mutable language, I am like, it's like I'm paranoid. I'm second guessing myself all the time. Like, hey, did that thing change the thing or not? Right? And I think like, so for example, Rust for me almost brings a lot of the same benefits because it makes that communication. Am I changing what you are passing around visible? And that's the thing that I care about. So like from my So the value that I put in functional programming, from my perspective, Rust is functional because that's what I care about. I want to know when things change, right? So I prefer immutability. I think it's the reason we didn't write the reason we wrote mutable code all the way back then is because that was the most efficient thing to do. But there is no reason for us to be writing like, I want a GC and I want immutability because it's 2024 and my hardware can afford that, and I'm not going to pay the price of not using those things, right? So that's where I sit. But there are some things that, like, doing a while loop is easier. Like, so one example is like, well, imagine that I want to change. So there was this example, is like, imagine you have like a list of items, like shopping items, and you want to change those items as you compute a total at the same time, right? You can do into separate passes. That's easy. You change the list and then you compute the total separately, easy. But you want to do a single pass, right? And now in functional programming, you're like, oh, okay, that's a map reduce, right? And they're like, what, right? So there are some things that, to me, it's like, I wish we could do better. And I've wrote like several proposals on this. I've opened up repository to collect feedback from other languages, and I never found something that is like that I would be like, that I was happy with, that I found a solution to the problem, right? Because the thing is, immutability wants to make it clear exactly how data is passing around, right? The while loop hides all that for you, right? So I appreciate the visibility that immutability gives me, but sometimes it just becomes sugar bowls, too much work to make all that work. So that's one example where, and there are people, I know there are people that they did not use Elixir because they could not grasp a map reduce, right? And yeah, right? So that's exactly like, I would love to remove that friction. I have no idea how, right? But it's there.
I do think it does. Functional programming definitely shifts some of the way that you look at how code is getting composed, and some ideas like map reduce, after you do it 50 times, it becomes very second nature, but there's a lot of off ramps to the language on the 50 attempts to getting that going. You had mentioned that one of the things you were really interested in what Go had done is bringing all of these tools sort of into the standard distribution and into the language. I'm interested to hear about the official Elixir LSP. Obviously, I'm a big LSP fan, and I'd be interested a little bit to know sort of the journey from having, community LSPs and that seeming like that was the right choice, and now like an official Elixir LSP. How did that happen? What are your thoughts? I'm excited for it, so I want to hear more about that too. Yeah, so just give us a little bit more info about that journey.
Yeah. So before we talk about that, I just want to throw up an observation that I have, that it feels that creating a programming language has become harder and harder, but for good reasons. Okay. So if you're going to LLVM is fantastic. So I can use LLVM and not have to do a bunch of things that otherwise I would have to do if I'm implementing a language from scratch. So we definitely developed, right, in that sense, and making sure that we have tools that everybody can use. But at the same time, like for you, like to have a programming language today, like we're talking about Go and the tooling, right? You need a package manager, right? Like, oh, Go did not have a package manager. Yes, you did not have, because it was Google, right?
Mm-hmm.
And they could just say, they could say you don't need one, and then people are like, maybe I don't need one. But if you were Jose Valim telling people that you don't need a package manager, people will be like, nah, I don't believe you, right? So you need package manager, you need documentation, and the wonderful thing about LSP is that now you need an LSP. It's like it's non-negotiable. People, they're going to expect an LSP. Before, they didn't expect that because the whole thing was fragmented, right? Like people would use like Vim and the experience would not be good, or Emacs for their favorite programming language. So it was like, how to say, a mise and something. And so, so sometimes maybe good, sometimes maybe shit, right? Mm-hmm. So, but now today it's a requirement, right? You have to. So there are a lot of things, and even like depending on this whole trend that AI is going, it may be that but I need my LLM to actually know about the programming language as well, which imposes a whole other barrier, right? Which is a really weird barrier because it's something that you don't have control, right? And you actually need data for that thing to work, right? Or maybe not because you generalize, but the things like this whole thing about tooling, how it has evolved, like let's say in the last 15 years, it has been increased the burden of if you are starting out, what you have to provide and what you have to work on, which is not like part of the language design really. There are intersections, of course, but it's outside of that thing. So so now going specifically to your question is, so like when we're going back, like Elixir is done, the whole thing is decentralized, right? Like that has been my general approach to the language. Like, you know, the language is done, but also to the community. I want everything to be decentralized. Like, oh, you want to organize an event? Like there is Elixir Conf, United States, Europe. There are events happening in other parts of the world. I'm like, you know, like just do it. Like we have the trademark guidelines there. Just go and do it. You can do it. Fine, go for it. I'm not going to be involved. I actually don't want to be involved, right? Because again, I don't have the resources to compete. Resource to compute I have, but not to compete. To with everything. So it needs to be a collective work, right?
Mm-hmm.
And it has worked out great for a lot of things. And at some point, and I'm not like, and I also say like at some point people were starting to get heated discussions like, oh, why we have 3 language servers, right? And then like, look, as somebody who created, you know, its own programming language, I have like zero authority to call out somebody for creating an alternative in something, right? Like I have zero authority, right? It's like you can do like somebody say, oh, like somebody copied like fork that library in the ecosystem. Like good for them. They should be able to do that. I cannot call out anybody on this, right? So, and for me it was good, right? To the point that but it was getting at a point where it was kind of like, you know, I couldn't show up on Twitter for somebody like language server, you know, that was like, okay, we have like, let's talk, right? So, and basically what I did was just like, hey, everybody, let's talk. And actually, and then I started gathering some people, and then Steve Cohen, which is it's part of the language server team, he actually picked that up. I was actually not doing a good job of putting people together, and but Steve, he was able to pick up where I started. It's like, okay, let's all get together. And then I was like, all right, you know, it's the official language server team, and I think it was good to have the different approaches, because when you look at the announcement and after they talk to each other, they really picked up like, they're like, oh, this one is actually doing this better, and this is a good idea, and this one is doing this better, so let's use that, and trying to come up with the best of everything. But for me, it's still is like, look, if you need Elixir to improve and Elixir to change, which we are doing the next release in a month, by the way, we are going to do that. I'm here to support you, but I'm not involved, right? Like this thing is decentralized. If you want to bring new people to the team, do it. Like I, you know, for most of it, I don't care, in the sense like I care, but I don't care, right? Like it's up to you, right? So that has been like my general approach to kind of everything. And for the language server case, it made sense to like get them together. Also because like I'm not sure if people realize how much fucking work a language server actually is, right? Like, you know, like Microsoft, like they had a whole project, probably cost millions and millions to prepare the whole .NET infrastructure to be good for tooling, right? And this is like people working, some of them like they are sponsored by Fly and Livebook, right? But these people working on their free time, right? Working on really hard problems. So I think they deserve, based on that, they also deserve like the recognition and appreciation for the work they have already done and the work they're going to do.
It's the truest statement that has ever been said, that LSPs are extremely difficult. They are even with all of the benefit of having like Rust and all of its extra utilities around creating these language servers easily with all the types and everything to find out, they are still just so dang hard. Like they are not simple. And so that's pretty great. But you did something which I thought was even more incredible. I know this is really hard. You somehow got people to agree that they're all going to use one format, like one formatting. We actually had a team of 12 people that wrote C++, and we spent 6 months trying to get everyone to use the same formatting, the project eventually died due to just wasted engineering hours of convincing people universal formatting is good. How did you do this? How did you accomplish this with such a fantastic tool?
So so the formatting discussion is really, like I actually did not want a formatter, right? So I guess everybody before using a formatter, like, yeah, I like, I don't want it.
Yeah.
But for me, like, I love a code formatter. And the reason why I love the code formatter, and here's what I tell to convince people, is that today when you're writing code and you don't have a formatter, you're actually thinking about the code, and almost always you are thinking about how to format the code at the same time. You're writing something and then you pass like open parentheses and then enter. Your editor is likely going to the first place, but you are thinking about formatting at that time, right? Oh, and something is placed, you stop your chain of thought to adjust things. At least I was like that, right? And then with the formatter, I just write like the dirtiest code possible. I don't give a shit. It's just like mashing at the keyboard, right? It's just like, oh, it's horrible, because when I press save, I know it's going to be good, right? And it's like, it's liberating. It's like immutability for me. It's liberating. I'm like, okay, I actually was thinking, like, there was this thing like in the back of my head, like, oh, fix the code. And now I don't have to care about this. And the thing is that, but the reason why we added the formatter was, so it was quite on in the Elixir journey. So what we're starting to have is actually teams that were starting to work together. And they were like, oh, we are a team. We want to write code in the same style to make the code base consistent and so on, right? And they did not have a tool, right? And so we started seeing those style guides pop up. And a lot of people, they were like, let's do how Jose do it. Let's write, well, Jose created it. He probably knows how to write Elixir code. And then people would come and like, why did you write code this way here, but not here? And then I'm like, it's like, the fuck I know, right? It's like, right? It's like,
found out. Yeah, they found you out.
It's like, there is no reason, right? It's like, it's just what I felt doing at the time, right? There was
that was Monday and today's Thursday.
Exactly. It was full moon back then, right? It's so and then they started asking me questions, and then they were like, oh, Elixir should put out a style guide, right? And you get from this conversation, like, I don't like centralization. I don't like people saying like, Jose should do this. Like, I love doing things as long as you don't ask me to do it. The moment you ask me to do it is the moment that I'm not going to do it, right? So at the moment people are like,
you're literally prime spirit animal right now.
Like, that's not funny, okay? I was gonna say that like a kid, but now it feels like I'm a kid now.
I'm gonna take this clip and I'm gonna send it to Prime every time he complains to me.
but yeah, like, but to me it's like that, like, like, there are things I would do with pleasure, like, and then people start annoying me, it kills like the whole pleasure of the thing, right? So
agreed. So
I was like, I don't want to do the style guide kind of thing, right? So I might as well solve it, like, we might as well have a code formatter. But then everybody is like, oh, but of course you're happy with it because then you wrote the formatter in a way that makes you happy. It's like, no, actually not, because I had no rules. Like, I was inconsistent everywhere, right? And then sometimes the places I thought was consistent, it's just not possible to format it with a rule in a way that becomes good. Right? So I was like, okay, we need to have the formatter. But if the goal of the formatter is to have everything, the things being consistent, it doesn't make sense to have a tons of different options, right? It doesn't really make sense. I don't want to have configuration. So we have some configuration today, but my rule is that the configurations, they should always converge. So there is no way, like, so if you flip a flag to true, maybe it changes the code, but when you flip to false, it doesn't revert. So you can say like things like, oh, force parentheses in places, right? And then the parentheses are there, but it's like force parentheses. It's not the opposite. It's not to remove parentheses, just to not force them. And so that was the idea. So I think our formatter does there are some people who are going to complain about this, like maybe if I go to my Twitter timeline right now, there's somebody like, I want this feature, but for the most part, like it's consistent for everywhere. And one of the things that we do is that in some places we keep the user style. So imagine for some reason you have a function call and you have like 6 arguments, and you have each argument in its own line because the argument may be complex, whatever. You have each one of their own line. So what a lot of the formatters do is that if you remove an argument, for example, it rolls back to the previous line if it fits, right? So you have this dance, the things is swapping all the time, right? But Elixir has a place like, look, so what Elixir does is that if the parentheses are open and there is a new line after, we are going to be like, we are going to respect the new line. And this is great because it...
This is great. One reason why I don't use code formatters is this, like the dance. I hate the dance.
Right. So okay. I have another one to see if it's going. It may disappoint you. All right. But yeah. So this is great because it removes the dance, and it allows the user to say, look, that whole thing in a huge line was like we cut at the line. We cut a line length of 98. Right. But if they're like, that's too ugly on their line, I want to break it apart. So it's like, I say, like, sometimes you want to give like breathing space to the code. You have the option of giving the breathing space to the code. The format is not like trying to find the minimal thing to squash everything in. Okay. Prime, TJ, what are your thoughts on trailing commas?
Oh, trailing commas is the single greatest mistake that JSON ever made. The fact that they said no to trailing commas and you just you can't move things around in the list, it's just mind-boggling.
Trailing commas gets a +1 from me, and I like it inside of function calls.
Yeah, I'm fine with
it. We don't support trailing commas.
Yes, it's great design decision. It's just always is because it's so easy to just copy a line, change a little quick thing, move on. You don't have to worry about the order and just crap. Now you forgot a comma in the past and all that stuff. I do have to. I have a quick question.
Sorry. To be clear, we do not support trailing commas.
Oh wait, what?
Okay.
I misunderstood.
Friendship just literally ended. You know that meme where like TJ and I are now shaking hands with something else right now.
Prime, do you see the time right now?
Yeah, I know. Gosh, I guess we gotta go.
Oh, so late. I gotta go look at regular Erlang now. Sorry, guys.
So actually, we do have trailing commas in the language. The formatter removes them. Okay, so we have something called the freedom formatter, which is basically the formatter with trailing commas. And so like some people who really want it, then they go with the freedom formatter. But yeah, there are some reasons. There are some reasons for why we don't do that. It's not like, fuck trailing commas. But I just wanted to disappoint you.
Actually, that's why it's there.
It actually sounds like it's a troll right now because you know that it disappoints. Like you could just mention it to anyone, they'll be disappointed. It's like that it hurts. Okay, I have one quick question. You do formatting on save, right? Okay, yes. Let's pretend you had something that's equivalent to an if statement in which you say an if statement, you put in the Boolean expression, you put a squirrely brace, new line, squirrely brace, and so you have it all formatted, ready to go, and then you save, and then does Elixir do like line editing stuff? Because you say you don't do it for, opening function calls, where if you have a new line, it won't bring stuff up. But do you do it for anywhere else? If there's no content, say, between the parentheses, does it bring stuff back up? I call them squirrely braces.
So generally speaking, we are very respectful of our new lines.
Well, can I pause for 1 second? Thank you, beautiful wife, for this delicious drink. She gave me a drink. Sorry. Beautiful wife.
Nice.
Chat wouldn't understand. Keep going. Sorry. I'm very sorry for interrupting.
This guy.
Don't flex
Oh, mine too. Actually, she just brought this down for me.
Totally
it's me
real.
Too. So it's just totally real. You guys don't know her. She goes to a different school. So anyway, sorry. Go ahead. What were you going to say about new lines?
I had to send a message. I'll be right back. Okay. No. So it's yeah, like we preserve the new lines, if I understand the question, right? Like, so if you do the if do and you break it apart, the things like we are going to generally like, even if a list like, for some reason you want to have each thing on the list on its own new line, we are generally very mindful of our new lines, also for separating code. So imagine that like, so we had like this kind of weird code cadence where we write like, imagine you have like a 10 lines in a function, right? Most people, they don't just like 10 lines, right? They usually add some new lines somewhere. We respect that. But if you have more than one new line, they're like, nah, come on, man. And then we would just like, we collapse that into a single new line. So we try to be like, okay, we are going to listen to you, except if you like training commas. And, and yeah.
I'm shambling.
All right. Well,
so hard.
speaking of the things that you type. Oh, nice. Speaking of the things that you type into your computer, I'm interested to learn more about Elixir's new type system. How's that for a transition?
You
guys like
actually,
that one?
TJ said to me that he has this really awesome transition, and so that was the transition is horribly disappointing.
No, it's typing in both sides. That's good. That's what we like to call a pun in the business. We're professional podcasters here, getting deliveries in the middle of our episodes. Sick transitions like this. I wrote down in the show notes, I've got a dope transition between these two topics. Let me hit it. I didn't write what it was going to be, and I'm banned in chat anyway. So, but I actually do want to hear about the new type system stuff for Elixir. And I probably best if you give a brief sort of overview of what types in Elixir is sort of looking like, your gradual type system, if you will, and sort of what's going on there, and then maybe we can probe around a little bit for some fun questions there.
How much backstory do you want, and how much tech stuff do you want?
It's your show, buddy. Take it where you want.
All right. So
I'm just going to be drinking his coffee.
This is a protein shake.
Oh, sorry.
I'll go with the. Yeah, I'll go with some of the backstory. So, like we talked about the formatter, right? And which was something the community was requesting, and we talked about Elixir being extensible. I'm completely out of focus. Okay, we talked about Elixir being extensible, and Elixir being done as well, right? But for me, it's like, look, there are some things that make sense to be in core, right? Like the formatter, if the goal is have unified formatting, it has to be in core, because otherwise, just not going to happen, right? And as Elixir grew, like I like to think we did a really good job of listening to the community and what were the nuisance. So after the formatter, people wanted like better experience in relation to deployment. So today, like you can get the virtual machine, your application, or whole dependencies in a zip file and run that in production, and it just works, right? There's even packages in the community like a Burrito that wraps that into an executable, and then you can distribute that. So like we have been listening to things, and then it got to a point, right, where when people would come up, what could be better? Like type system would like frequently come up. I remember there was one Elixir Conf where I asked people like, hey, like I asked for a show of hands if they would like. I did not say a type system. I said, would Elixir to go more in the direction of have more static checks happening in the language, finding more stuff at compilation time, and the general show of hands was like, yes, we want that, right? And there are like some things that's like it's very worth talking about, is that Elixir is a dynamic programming language, but it is very different than JavaScript, Python, Ruby, because one of the things that make programming hard in those environments is the duck typing and the polymorphism, right? Where you're usually passing things around, right? And you don't know what that thing is. And then you're saying, oh, this thing can be any argument as long as that argument has a toString function, right? So we are defining those protocols, which I think it's fine. Protocols are very important part of software, but often those protocols, they are in those languages, they are undeclared, right? It's like it's a very loose ad hoc contract. So Elixir already feels very different, and we do find things like undefined functions, where those other programming languages, they're only going to tell you about undefined functions if you have a type system, but Elixir is going to tell about that by default. So you're kind of like, of the dynamic languages, we are probably the most static, if that makes sense, right? Like the types are still known at runtime, have a great deal of flexibility, right? But we are quite static. But it was still something that the community was asking for. And actually, in the talk where I said that Elixir is done, I troll the audience, because I have one slide that was saying that we started working on a type system, and then everybody started clapping. And then the next slide was, we stopped working on a type system because I could not figure out how to make the type system work. Right. And then people clapped, like half of the people were happy. And then the next slide, like the other half was happy. And I was probably the one truly happy. But so I tried and I could not figure out, right? And it is very funny because like I tried to implement the type system, I built a prototype, right? And then it was very slow, right? And I'm going to talk about it now. And the reason why it's like, so working on a type system is actually like, it's very, very hard, especially for an existing programming language. Because if you are starting a new programming language with a type system, those two things, they walk side by side. And they're like, hey, I want to add this feature to my programming language. Oh, do I know how to type it? No, I don't know how to type it, so I'm not going to add the feature. So you can make the constraints of designing the type system in the language walk side by side. Elixir is an existing language, right? So, and one of the things that I realized that, look, I don't want to add a type system if adding that type system means that you can only use like 80% of Elixir. Because then that's no longer Elixir. That's something else. That's another programming language. That's not Elixir, right? So, and then the thing is, like, if you are designing a type system, one of the things that you may want to have is like type inference. You want like the types of your function signature to be automatically inferred. But the type inference comes with trade-offs on type checking time, such that some communities, they're like, oh, compilation times are slow, add some type signatures, right, to your function. So it has to do less work. That's the thing, right? And if you want to have type inference, it restricts even further the features that you can have on the language, because you need to make sure that any construct that you add to the language, type inference is going to work and is going to be efficient and so on. So there are a lot of trade-offs, right? So I implemented one and, obviously failed, right? And what was really fun is that I read like 7 papers around implementing it. I built a prototype, and then I went to talk to professors, researchers that are known. And then I was like, look, I built this prototype, but it's like very slow. And then they're like, yeah, it's known that they are slow. And they're like, what do you mean it's known they are slow? Like, I read like 6 and 7 papers. None of them told me that this is going to be slow. And they're like, yeah, because the paper is not interested in discussing the implementation, right? It's only discussing like the theory. And they're like, okay, it's slow. And then I realized, look, I don't know how to type Elixir in a way that is going to be fast, in a way that's going to be satisfactory, in a way that is not going to feel like I am removing features from the language for the benefit like of typing. And saying that, like, in this new work that we are doing, we may remove features from the language, okay? But it needs to be justified. It's like, oh, we are removing this, but it's a shitty feature anyway, right? It's like, this is a bad idea. You should not be writing that code. That I would accept, right? But I also don't want to like,
Can I don't want to 1 second? How like hesitant are you of removing features or changing features? Because that sounds like such a Python 2, Python 3 mess. Like that, hearing that just sounds like that has to be such a weighty decision to make when it comes to that.
So we basically like we don't remove features, right? So my goal is, so everything that we feel like this is no longer good, this is discouraged for as much as possible, right? And that has been the history in general. We deprecate it, right? So if we can deprecate it, we deprecate it, and we deal with it with the rest of the time. And there is actually, and I have a whole other rant about deprecation. We can go back there, or about breaking changes. We can talk about this later because it's going to be the detour of the detour. But yes, I don't want to remove features. My goal is if something doesn't work, we're going to deprecate it, and then in 10 years from now, when I'm like the type systems incorporated, we figure out all those things that have been bad. Those things have been warning for 3-4 years. I'm going to release Elixir 2.0, and that release is basically removing deprecated code, which means that if you're running your code in Elixir 1.0 and it ran without warnings, it should just work on Elixir 2.0. Like, there are 2 things in the issues tracker, I believe, today that is scheduled for 2.0, but they are like very minor things. Like one return type of something nobody's using. Like, they are very minor things that we want to change, but it should be very minor and it should affect very few people. And one of the things that I want to do when we are getting closer to that is to have like Python has this thing import from future, but I want to have like a spin on it, which is like I want to have like an Elixir future flag that when you set it to true, it runs with the changes, with the very few changes that we want to use for Elixir 2.0. So everybody running on Elixir 1.0, they can add to CI like Elixir future environment variable set to 1, and then it changes a couple things so they can get a feel for that thing on the CI, on testing, that everything is going to be compatible. But yeah, like, like not, no breaking changes. I'm going to do my rant anyway, right? The thing is about breaking changes
Let's go.
is that, right, is that the thing about breaking changes is like some people, they tell you like, look, we have to do breaking changes. Like, there are languages, there are frameworks that do this. We have to do breaking changes because
React mentioned.
if we don't do that, we cannot evolve. That's the rationale, right? If we don't do that, we cannot evolve. And if they say this, it can only mean 2 things. The first one is that, one, it's bullshit. They are bullshitting you. They can actually they're just lazy of maintaining compatibility, okay? The second one is actually worse. The second one is that they're actually being honest and saying that they cannot evolve, they cannot add features and maintain compatibility at the same time, which is worse because that should be a huge, huge red flag. If you have a framework telling you that they cannot evolve and add features at the same time, what that's going to tell you about your application, right? Like, you don't have this luxury. Like, you're working on your application, you have a client that maybe your company is like changing directions, but you have that big fat client that you still have to maintain. So you have to maintain the old code and the new code. Like, we are dealing with those problems every day. If my framework tells me they cannot evolve and maintain compatibility at the same time, I'll be packing my bags and going home because I'm like, look, there's no hope for me, right? Because now I have to deal with the changes of the framework, right? And the framework people, they are telling me that their programming language, their environment, or whatever is not going to support me to do the compatibility. So I would just pack my bags and use something else, right? So yeah, so it's so I really like, I'm not saying that, oh, you should never have a breaking change. We had like breaking changes in Elixir, and we say like, look, sometimes we have to fix a bug and it's a breaking change, right? Like, things are going to happen, but I strongly disagree with if somebody says we need to do breaking changes because we have to evolve. Like, for me, it's a huge red flag one way or the other.
Hey, it's Prime and TJ, and we make courses for boot.dev.
It's a super cool site to learn about back-end software development where, to start, all of the content is free.
Absolutely free.
But the cool thing is, if you want to do the online interactive exercises, get help, and join the cool Discord and score a little bit of gamification, then you can buy a subscription to boot.dev.
And if you want 25%, use code, by the way, BTW.
And that supports both me and Prime. So it's a really nice way to both get access at a discounted price and support both of us. So thanks, everybody, and we'll see you on boot.dev. Bye.
It's great.
I think one of the cool things for the type system, everything I've seen so far, is there's literally no changes to anybody's code to get a bunch of the improvements that you guys are shipping inside of the new versions of the Elixir compiler. Am I understanding that correctly?
Yeah, so going back to the type system, right? So I was like, oh, I don't know how to do it. And then I said, like, there was some period where I was thinking I was done. And I was like, oh, maybe I don't have anything to work with. And what happened is that at the end of the year, somebody, two master students, I believe, from Uruguay, they sent me their thesis, which was about their master thesis, which was about adding a gradual type system to Elixir. And I was like, oh, that's very exciting. And then I asked them, like, do you want to work on it? They're like, nope, we are never touching university again. Nice to see you, right? And good luck. And I'm like, very understandable. And what I started, and then I read the paper and I read the references. And as I was reading the references, there was a lot of citations to Giuseppe Castagna, which is a very known researcher in the area of type systems, has a lot of papers, all this kind of stuff. And then in one of the papers, the paper is like, look, in this paper, we are going to show how to solve this problem. Okay. And that problem was one of the performance issues that I had like 2 or 3 years ago. And I was like very excited. I was like, oh my God, this is great. Like maybe I'm going to be unblocked. And then I go on reading the paper. And then the third section is like, let's formalize that problem. And they're like, math everywhere. Right. And then like fourth section, here's how we solve math everywhere. And then like finally the summary, we have solved the problem. And I was like, okay, how do I implement this? I have no idea. So I sent to him an email saying pretty much that, right? And the irony of it all is that we've published the paper together, and there is the middle section of the paper, which is formalization. I don't understand. I am one of the authors of the paper, and I don't understand. But we started talking, and then we're like, oh, maybe we can work together. And then I started reaching out to some companies in the Elixir community to be sponsors of this thing. And then the project started. And at the very beginning, and I still like today, I'm way more confident. But at the very beginning, I was like, I'm not sure if this is going to be true, because there's like really an open question of how much of Elixir we can type. Right. And we actually had to develop, we means not me, like there is Guillaume Duboc, the PhD student, and Giuseppe Castagna, Beppe. They actually had to develop new theory. So there's like new type system theory existing today, right? In order, which should make it possible to type Elixir, right? But even if you're like, look, we are very comfortable with what we were able to do with model like the huge majority of the language semantics, the paper talks about this, is still like, is this thing actually going to be fast, right? I don't want to make compile times twice slower, right? Like that may not be worth it, right? Or 3 times, I don't know. There's going to be a threshold where I'll be like, nah, too much, right? And are the error messages going to be good? Because if you're like, hey, we found errors, right? But good luck understanding what this error means. That's not going to be helpful either, right? Like, so for example, we have a tool in the community in Erlang called Dialyzer, which finds like typing violations. And Dave Thomas, he described the tool really well. He said like, using this tool is like talking to a monkey, like the error messages from this tool. It's like talking to a monkey. You know that the error message is correct, but you have no idea what it means, right? It's like, there's a way to improve, there's a path to enlightenment, and they're like zero idea on how to get there. So it's like, so there are all those things that we have to solve. So what we did was like, look, what I want to do is that we are going to, one of the work that was done is like, so in Elixir, we have pattern matching and guards. So that was saying like Elixir being statics, that most of the time you actually know the types that you are working with. Right? It's like we don't have a plus that works with arrays and strings and integers. Plus works with numbers, right? Which means that if I'm calling a plus, I know that the arguments are numbers, right? So if you look at the program, right, you know like what you're getting, right? You know like, oh, this has to be a number and it's going to return this. So the functions, they can be polymorphic, they can accept different shapes, but in a way that is very constrained, very restricted, and we can actually analyze the source code for that. So what we are doing right now is that we are getting all the Elixir code base, right, that are out there, and we are doing inference of the patterns and the guards, right? So we are figuring out the type of those can you hear me well? I feel like in the feedback. All right.
It died there for a quick second. Ping was dying, but we could hear you. It's just your voice got a little off and all that.
Yeah,
We're back.
the face is not important. All right. Yeah, so we are inferring the types of the arguments using the patterns and the guards and having that flow through the program. So, and this is great because it means that we are using information. We are using the code that you already wrote today to find bugs, to find things that we are 100% sure there are bugs. There are some cases where we may introduce, like, we may say, oh, we think this thing may fail, because that's the other thing about type systems. All type systems, there is code that you write, and you're like, this should work, but the type system cannot prove that that code is correct. And it's like, no, you cannot do that. Denied, right? And it would make total sense. It's just that the type system cannot understand. So by adding a type system, that can happen. But in the stage we are right now, I want to look at existing code, automatically do type checking. You don't have to change anything. And it's a good thing for us to assess the performance of the type system. It's a good thing for us to assess the error messages, make sure that the error messages are good, and collect feedback. So we can do all this work without changing one single thing in the language, which means that if at the end of like this milestone, if we are happy with it, then we can much more confidently say, okay, let's do this for real, and let's allow people to write type signatures or whatever. So that's in general the type system work and how we are approaching it. So I still think there is like really, we are in this milestone of trying to understand more and more about your code. And it's like, so TJ said, like, it's a gradual type system, right? Because it's a gradual type system in the sense it has dynamic, but you are implementing it gradually. So I think we're still going to be on this journey maybe for like a year or two till we got to make the decision, okay, we're adding type signatures to the language because we feel quite confident that this is the way to go.
I'm excited. I really like types. They're it's just something that I really appreciate in languages, and so I'm very happy to hear this. But it seems like what you said, pattern matching and a lot of these guard clauses kind of get you a huge percentage of the way already as it is. So this seems very exciting. I'm very excited about it. I do have one quick question to kind of reconcile a couple things you've said, which is you talk about the consistency. You don't want to do breaking changes. We're going to go back to the other side of this rant, which is the deprecation. If you've used any JavaScript ecosystem, project long enough, and you've let anything go, and you try to update, it's just everything breaks all the time. It's a huge struggle of any sort of long-lived project. If you depend so much on the community with Elixir, how did you distribute this mentality of always having backwards compatibility, or does the Elixir community suffer the same way as the JavaScript community, where there is always a lot of breaking changes going on?
I think the Elixir community in general does a really good job as well. So, for example, Phoenix, I think the 1.0 came out in 2016, and it's still 1.0. It's not 1.0. It's still 1x, right? It's 1.7 or 1.8, right? And it follows some ver. So what changes in Phoenix is that it changes like the generator, so if you're starting a new app, like the create app thing may generate a new structure because we find new things. But if you have an existing app and you update to the latest, it just works. Sometimes like there is a new configuration you need to set, but it should really be a question of minutes, hours best. It should not be days, right? And then like we have a tool for talking to the database called Acto, which did have some churn because, and I was involved in that too. And at the beginning, it was really hard. Like, how do you have? It's a functional programming language. Like almost everything is a ORM, right? Object relational mapper. We don't have objects, right? What does it mean to have a tool that talks to the database in Elixir? So we did some steps. We did wrong things, and then we launched its on Acto 3. So we had like 2 major versions with breaking changes. But I think this is like from 2018. So it has been like 6 years, right? Like the same major version with no breaking changes. So generally, like we are very mindful of that. And that's the other thing, right? I also think like it all goes back to that idea of like every time you do those breaking changes, you're actually like pushing a huge amount of churn to the community, right? To library authors, to application developers, people that could be enriching the community in other ways, and you are getting that energy to deal with the deprecation, right? So you could even think about it. It's like, every energy that the Elixir team puts in not breaking something, maybe even if it's hard, right? It's like, it's going to be like just a small fraction of the energy the community would have to put if we do break something, right? Like I'm not saying like I never broke compatibility, like sometimes it's going to happen, but like that's the equation. That's the thing that I care about, right?
Awesome. I love that answer. We are now going to transition into our Q&A section from the audience now. So if you are part of the Top Shelf in Discord, go over there now and send some questions. We'll start off with somewhat a lighter one, a little easier one. Do you have any other functional programming languages you enjoy outside of Elixir and Erlang?
Functional programming languages or any programming language?
It can be any, but in particular, we'd love
Okay.
to hear if there's an FP language that you like.
Oh,
And why is it OCaml?
You can't seed it like that. I wanted him to come to it naturally so I could clip it and use it as my subscription sound.
All right, I had something prepared. So what is that? This may bomb. What is that programming language from MIT with the visual blocks?
Scratch.
Scratch.
These nuts.
Oh, he did it. He did it. I knew that one was
All right,
coming.
I warned.
He specifically
okay.
asked
I
if he
had
could
to
do
do it.
one. I knew it was coming, but we had to give it to him. We had to give it to him, boys.
I was not ready. I know, TJ, don't even pretend like you knew that was a D's Nuts joke.
Dude, he asked in the DMs. Do you not read the DMs?
He
literally
did.
asked.
First off, I answered it, but I did not see that one coming. Okay, I was D's Nuts.
Okay, I'll admit, he got me. I'll just admit it.
All right.
That was good.
Yeah, it was actually. I have to do the shame. Say like it was not like I got caught by this one as well from my coworker Wojtek. He yeah. So anyway, what was the question? Programming languages. Right?
Other languages
there's-
besides for Elixir. What's your go-to other language, functional or not, but preferably answered from a functional perspective? Is there one that you really respect, and then you can
like
grow from
yeah,
there?
if it's respect is like it's very hard for me because like I'm doing Elixir most of the time, right? Like so I am not there are not a lot of languages that I'm going to say like I go and do write some Rust from time to time, but I would never say I am like proficient in Rust nor anything. Do have to write some JavaScript from time to time. Like we all have to step a little bit out of our comfort zone. So and the thing is like when I was starting Elixir, I was like obsessed about like all different kinds of programming languages because it was all about like absorbing all those different ideas. So like Clojure is a huge inspiration to Elixir, right? For me, it's like a top 3 inspiration. So like if we are going to go with that sense, I would definitely put Clojure out there. I think like if Elixir would not like the Erlang VM would not exist, I would most likely be writing Clojure. That's how I like to think about it. But like there has been recently I started like looking more into like programming language researches, programming languages that are coming out. So they're like with new ideas. So one is called, I believe it's from Microsoft, called Coca or whatever you're going to pronounce it. And what they're I haven't really used it. I don't know the experience from using it, but from the point of view of like, oh, they're exploring different ideas. It's like, that can shape how we may be programming in the next like 5 to 10 years, right? I think like it can be really interesting in how they are getting ideas, for example, from like Rust type systems and knowing when things can change and applying that to functional programming languages. Very interesting. There is also Rock, which is getting the ideas from Richard Feldman, like it's getting the ideas from Coca and actually putting that into an application with a bunch of his own ideas as well. So I would go with these two, and I would also do a shout out to Unison, which is exploring new ideas in the area of I don't know if I'm pronouncing that correctly, but exploring new ideas on the area of distributed programming. And I want to give it a shout out because Joe Armstrong, um, the creator of Erlang, who passed away, I think he would absolutely love Unison. Like when I would talk to Joe and the ideas that he would have about programming languages, it feels like a lot of those ideas, they are there in the Unison programming language. So I definitely, if you want to have like your mind expanded a little bit, definitely worth checking out as well.
So
I'm just going to throw it out there. I'm just saying you are looking for elegant ways to handle mutability. I think OCaml has some really nice ways in the functional programming landscape, just throwing it out there, and is also getting some cool stuff with effects and other. They're just throwing it out there. Throwing it out there. That's it.
Yeah,
Sorry, couldn't help myself.
No, it's really good. Like the whole effects things, like fantastic in my opinion. Like you can generalize monad in a way that feels way more intuitive, doesn't have a scary name, and it's more powerful than sounds, all these developments like very, very, very exciting.
So I do think there is kind of an interesting question here, especially just from the perspective that a good 25 to 30% of everybody in the chat, or usually in any of these videos that are watching it, tends to fall into the newer programmer category. The other 70% is usually in the mid-level to experienced programmer. And so what is your best advice to a beginner? Should they learn Elixir as a first language? Also, huge inspiration to all of us Brazilians.
Oh, that was a question. I thought you were asking. And then when you said huge inspiration to all Brazilians, like, what?
Yeah,
You're Brazilian, bro?
I am not Brazilian.
Yeah, I got it.
I've been to Brazil.
I got it.
I've enjoyed Brazil.
Fantastic. Yeah, so so I'm going again, like we all learn like in very different ways, right? But for me, the thing that makes it work and makes me have like a pleasant discussions with people, and that's what I see, for example, when you are analyzing the blog post, for example. Something that I really appreciate, I think everybody should try to build this skill, is to analyze trade-offs, right? To understand like, hey, this thing is happening because of this or because of that. What are the positives? What are the cons? It feels like we don't have a lot of discussions about trade-offs in general. I think Rich Hickey had a good quote on this, or said like, programmers know the benefits of everything and trade-offs of nothing, or something like that. Right. So that's something that I would like develop and try to explore. Like how to do that, I'm not exactly sure. For me, it works like I like to poke around with everything, play with different tools, go deep, play with the source code, fiddle with things, right? And try and never get like, oh, this is better. It's like, no, like what is better, right? Better in what? In how? Under which scenarios, right? Like asking those questions to try to build this intuition of when you want to do this thing, why you want to do this thing, right? And the good thing about this is that when you know how to discuss trade-offs and understand them, you become really good at agreeing to disagree as well. So, for example, I was talking about Rock, Richard Feldman, and who is the creator, and then I have discussions with him where I think we probably we take very different design decisions on stuff. But when we discuss, we all agree on the trade-offs. We are like, oh, there's this trade-off, and there's this, there's that. And it comes at the end, I may say, okay, I value that more. And he says, I value that more, but I completely understand his decision and why he picked something and why he would do another way. So I think that's where I would go. Like, like as like in a way it can be like, be curious, question, that's the thing, but like not being like the questioning in the asshole way, kind of, right? There is a line there where that you can navigate. But I think like the trade-offs discussion and pros and cons, it's very important.
All right.
Awesome.
So
I've got that.
Oh, sorry.
It's my turn.
Okay. Sorry. I didn't realize last
I didn't even
time we
get
didn't
any cool
trade back and
deliveries
forth.
today.
I just did it all. So I wasn't sure what
okay.
the game was here.
Oh, I thought we were on a podcast together. Okay, so here's a bit of a longer one. So just give me some time to read the whole question. It's a good one, I think. Elixir is known for its strength in concurrency, fault tolerance, and distributed systems, which makes it perfect for building scalable and resilient apps. As a note, I can second this. It is quite nice for that. Given that, I'm curious about how Elixir could be applied in the world of cybersecurity, especially for both offensive red team operations and defensive blue team tasks. And then there's some examples of supervision trees and how those could be helpful for command and control. I'll sort of skip through some of those, but get to the end. Why do you think we haven't seen more use of Elixir in these areas, especially considering how popular languages like Go and Rust have become for similar purposes? Is it due to challenges like low-level system integration, a steep learning curve, or are there other reasons that Elixir isn't as commonly adopted in cybersecurity?
I would like to add one quick thing to that as well, which is also on top of it, why aren't functional programming languages just really mainstream at all? Like if you could answer the more narrow one and then kind of graduate into like just the functional paradigm in general.
I think the answer is kind of the same in the sense that I think like adoption there's very little relation to technology. There is some relation for sure, but I don't think the major driving forces of adoption are necessarily technology, right? And I think, so if we're going to say, oh, what is blocking Elixir in cybersecurity, right? Maybe it's just a matter that nobody had a stake on it, so there is no use case that somebody can point to, right? Or if there is, it's not talked about publicly, and because of that, there's nobody replicating that, doing their own bet, and then it doesn't start, right? So it may be something like, oh, it just takes one brave soul to start that, right? And with functional programming, of course, with functional programming in general, we have like a wider industry adoption, right? And the ideas for functional programming, they are older than object-oriented, right? So I think when it comes to functional programming per se, is like, yes, those ideas, they were there early on. They were not. I love to do comparisons with like the garbage collector. I think like the garbage collector was introduced in the same paper that introduced Lisp. I think it was John McCarty who introduced it, and it's from '59, right? And it took 4 decades for us to like start using it. And functional programming was definitely ahead of its time, right? So we all got used with other ways of programming and writing code, but now we are at a point where like the moving force, right? It's much harder to change. So that has been like kind of my general thinking when it comes to adoption. There are things that like the supervision trees is also like really good for like embedded software, because suddenly Bluetooth stops working, right? You just want to restart that driver. Wi-Fi is not connecting. You wanted to restart it as well. So it can be applied to a bunch of things, but the technology can be great. But the adoption forces, they are going to usually go way beyond technology. That's my thinking. Maybe it's a coping mechanism, but that's my general thoughts.
When you say way beyond technology, do you mean, just the reality is that most college students, most kids coming out of boot camps, most self-learners kind of fall into like a JavaScript or a C for embedded because they're doing hardware, or a C# for game programming because they're doing Unity, where they're just kind of like not even exposed to this side. Is that kind of these root cause for things outside of it, or is it simply because it is actually just a harder way to think and it's harder to get into it?
No, so I don't think it's necessarily so. Okay, so there's one part that I want to say is like, because somebody said Elixir is a first programming language, and I don't think we can say that one is easier than the other. I don't think like maybe somebody can try to do studies, but I actually have no idea. I'm not going to say either way, but I just want to say like, I don't think Elixir would be harder to learn, right? Because a lot of the things when you're learning Elixir is about unlearning, right? Especially if you're coming from an object-oriented background, right? So like, and I think, we were talking back then about like functional programming. And I really think that, in the next years that we are thinking about how we're going to position Elixir, I think functional is going to play less of a role, because again, the goal, like, what does being functional mean, right? It's like, you have Go that doesn't have objects, right? And they're not saying that they are non-object or whatever, right? So, but I don't think one is harder than the other. But a lot of learning Elixir is like, and the same with Go. It's like, oh, you no longer have objects. Now you have to think about like data structures and interfaces and functions as different things. How is that experience? There's a lot of we're learning that. So I think part of the issue is the pipeline, but I also think like part of the issue is, it's things that have happened 2-3 decades ago, right? JavaScript would not be a thing if it was not on the browser, right? Most likely it would not be a thing.
Correct.
Right? It would not be where it is today, right? If I had invented Go, since we're talking about Go, right? And not throwing shade, but if I had invented Go and Google invented Elixir, how would the adoption curves compare at this point? And look, I'm not trying to take merit from what like getting a language like used at the scale that Go is. There is, of course, technical excellence, there is technical merit, right? But there is a lot of things that, it's not about the technology, right? Like if one of the biggest 5 corporations in the world say that's the language that we are using, right? So front facing, that's a huge push that, it's very hard for other languages to replicate, right? Like my hope is that there is a startup starting now that invests deeply in Elixir, and, maybe something will happen. They're going to be huge in 10 years, right? And then they're like, Elixir is our pro language. And then we are going to be able to replicate that level of influence, right? So it's all those things. And again, like I'm not taking merit from anybody, right? Or anything, right? It's like we could also talk about Python. It's probably the most popular one today, right? And it had a whole different trajectory than Go, right? And it was the language that people loved at the time when they were doing scientific computing and the other ways that Python grew, right? So it was able to conquer the hearts of people, and today it's hugely influential, right? But all those things, right? Those are all different scales and comparisons that we are thinking about adoption. So I think like the marketing front, like huge important, right? Like the largest the corporation that are pushing those things, they all play like, and then it goes back to the tooling, right? Like, oh yeah, TypeScript, right? It's like, a $1 trillion corporation working on the tooling, right? And the tooling is going to be great, and developers are going to be happy, right? So that's how I think. It's like it's a whole, holistic approach that is going to lead to the adoption, rather than, oh, we have a better concurrency model, right? Or it's immutable and we have Lisp style macros, right? So.
Well, I'm surprised that I actually would think that having a good concurrency model in today's day and age actually is very appealing, because TypeScript and JavaScript does have, appealing single process concurrency, but the moment you need to scale your machine, it's a non-trivial process, right? Because you have to have a supervisor of some sort of worker. It's just like there's so much more effort you have to put in to do the exact same thing. So there is definitely something. I think we're growing towards the appeal of it, or it's going towards the serverless, like you just never think about anything except for a few quick calls and calling it a day. But we got another
And the bill at the end of the month.
Yeah, I'm not here to dunk on those zeros, but there's a few. I know many zeros, and there's some zeros there. All right, so this is a question really for me as well, which is I have a lot of experience programming. I can kind of read OCaml. I kind of know what I'm doing, generally speaking. I understand recursion, so that's a bonus in pattern matching. If I was a noob in the Elixir world, which I am, where is the best place to start?
What do you want to build, right? So, if you want to do web development stuff, maybe try with Phoenix Live View. If you want to if you like what we're talking today, is like, oh, concurrency and distribution, then maybe build something related to that. So like, for example, in the getting started, in the getting started of the language, we actually show you how to build like a distributed key value store, right? So it's like, I don't think there's any any other language doing that. Maybe Erlang can do it, right? But so it really depends on where you want to start. We are like now doing a lot of things with machine learning, very bleeding edge, right? So it really depends. Maybe if you want to do like some code solving exercises, start with Advent of Code. But it really depends. I think one of the things, so we were talking about other programming languages. Like I always took Python as a model of what an ecosystem should be, in terms that it can do so many different things. And I remember going to a Python event like 12, 13 years ago, and then it'd be like, oh my God, like there is somebody talking about like network, and somebody's talking about like Jupyter notebooks, and somebody's talking about Django. And I was like, this is great. Like this is the diversity that I think it's good. And we're not there. We strive to get there. So I think it's really going to depend. Like you can go to the Elixir forum, ask questions about what you should do. But I think I started with Erlang, writing my own programming language, right? It's like that doesn't make sense, right? So get the thing that you think you're excited about and try to solve. And maybe it can be frustrating because you may pick something that there is not a lot of things. There was like a recent discussion in the Elixir forum. Somebody was like, oh, I want to implement like my own WebSocket, right? And there's no documentation about this, right? And then they're like, yeah, because like somebody has implemented a WebSocket server in Elixir, and we all just use that, right? So we don't have documentation on how to implement it. We have documentation on how to use one, but not on how to implement it. So depending on what you're tackling, it can be frustrating, but it can be good, like managing that frustration and going different things. Yeah.
I would definitely say like Phoenix and LiveView is a really cool place to start. If people are looking for one and they just want to try something where I think Elixir really shines, I'll just shill it a little bit harder than how much it's getting undersold here on the interview, because I think it's super cool. And I think it really gives you a peek into a lot of the ideas of how the actor model can really change how you're thinking about your applications. If you're used to sort of just one process and shared mutable data and all this other, it's just, you're like, oh, this is very different. So I'll shill that one a little bit harder as a worthwhile place to start.
But I think
really
what we
cool.
were looking for is more like boots on the ground place to start. Like, should I just start at the documents? Should I read through the language, kind of look through the docs? Like, what is a bit more of a concrete location as opposed to just live view? Because I do want to look at live view. I know it's out there, but it's not necessarily my first place to look.
Fantastic. No, yeah, perfect follow-up. So things you can try. So people in the chat was saying there's a book called Elixir in Action. Really good, really excellent. It assumes that you've programmed something before, that you have some programming experience. So it's like, we are going to say string. We're not going to explain what a string is, right? Really good book. And there's also a talk from Sasha, the soul of Erlang and Elixir, that people mentioned in the chat. If you go to the website, we have a learning section with links to books, screencasts, and all the other things that you can use to learn. We have good API documentation, very introductory. We have good API documentation, but also a getting started guide that is fast paced. Go through the language, and then later on we build like the distributed thing I was talking about. So like learning resources, we have like plenty of learning resources. If you want live, you were talking about, there is a programming LiveView book from Prague. There's a machine learning book from Prague. So in terms of resources, we are actually like quite good, and people are very welcoming and active in the like Slack, the forums. So those would be the place that I go. I would also just mention Livebook, which is like Elixir version, like not really, but Elixir version of Jupyter notebooks. And if you just want to play things around, so if you want to do Advent of Code, I recommend, it's open source. I recommend like doing that in Livebook. It's going to be a really good programming environment. I also have a talk on Livebook, which is where like I live code a distributed machine learning application in like 20 minutes or something, like directly in Livebook. So it can be a good place to check out and see what you can build there. I think I know the chat's like just posting a lot of things in there. So
Yeah, don't worry about that. Could you link me those chat or those books, and I will make sure I get them as like a little resource group that I will get it out to the chat or maybe put it into the YouTube video. Just put us in the whisper with TJ. All right,
I'll
so
do that. Yeah.
I'm going to do something a little strange now. So I'm going to need your focus because we're coming to an end, and so I just want you to answer yes or no to the following 5 questions.
Okay.
Self-driving cars in 5 years.
Nah.
Will you
I live in Europe, okay? Oh, it's just yes or no.
Yeah,
Okay.
come on, we're going fast here. Solid-state batteries
Sorry.
within our generation.
Have no idea what it is. No. Yes, maybe. I don't know.
That'd be like instantly charging batteries that last for days, as opposed to like your phone running out in a day. Like they go a long time. All right, well, fine. Quantum supremacy. Will it happen?
Nah. 5 years? No. Supremacy now.
Do aliens exist?
Yes.
Did I say 5? Was that 5?
I don't know. I kind of
that was the
cheated.
last yes or no question. The answer was no, but
All
then
right,
yes.
all right. Will AI replace programmers?
No. 5 years? No. Maybe that's copium, the last one. But yeah.
All right.
All right. Yeah.
Based.
No, like the self-driving car, it's like, look, I live in Europe. Like we are not passing regulation in 5 years. Okay. It's like even we started today, it's like it's not happening in 5 years. So
Fair.
that was an easy one. But yeah. But
Okay.
let's talk about aliens, because they have to exist. I mean, the universe is huge.
Do you think so?
What are the odds?
I have a very
think
simple
so.
answer why I don't think they exist. Which is that it's like our universe is billions upon billions of years old, and if our society can continue on, then we will be able to travel the universe in not even the fractional tiniest bit of the universe continuing. So by now, if there was another life form, unless if we're all of equal amount of, like we're all created at the same point, and we're all moving at the same amount of speed, it would just be so unlikely that there wouldn't already be stuff that's completely able to travel the entire universe and everything. It just feels so ridiculous to be like, well, they can't. No one can travel the universe. No one ever figured it out.
Hear me out, though. Hear me out. If the only programming language that the aliens invented was JavaScript, I don't think they're leaving their planets. So it's not really super obvious that your analogy works, Prime.
Yeah, I know there's also like the Fermi paradox or the dark forest and all this other stuff. I just don't think that's the case because like look at what we're doing with our planet. We're just like ejecting stuff into the universe constantly. Be like, hey, we're here. Like you think you'd see something at some point being like, yeah, there's loud Alabamans also over on that planet as well. Look at us go.
Yeah, like I'm reading like there is this I can show books, right? Like there is like Hail Mary book.
I mean it
I'm
depends on the
reading.
book.
Well, I also in this drawer. So and like there are some interesting ideas. I'm midway, so no spoilers, but it's like right, like I think so what is interesting about the books, like they go to an alien and then I think like they don't have eyes, for example, so the way they communicate and see is completely different, and then like they perceive band waves, spectrums like completely different, and this is the imagination of a human, right? It's like and from the imagination of a human, it's like like things can be like completely different and just like being using with different spectrums or doing all kinds of different things, which feels like in the probability and the size of everything that is happening in the universe, right? Something has to have happened, right? And
one question: what's
so
the probability of life being created?
I don't know.
Yeah,
Tonight,
no one knows. We actually don't even know if it's probable. We don't even know what it would take, right? We can't even recreate it in lab with perfect environments. So it might just not ever happen again. There might be only one time, right? The fundamental flaw of Drake's equation is that we don't actually know the probability of life. So we go like this. There's enough of those planets it eventually works out. It's like, maybe not. Maybe never.
No. Yeah, I had a joke about the probability of life being created. Um, but yeah,
And what's the joke?
well, tonight's going to be 100%, baby.
I thought he was gonna. I was gonna say, ask your mom.
Oh
No.
gosh.
Uh,
Am I just the only one falling for these days?
I thought you that one. That one, I knew that was coming that time. I'll admit, I got by the scratch joke, but I knew that one was there.
Oh, wow. What a way to end this interview, huh? Hey,
And there
Jose,
was
Are we ending here?
is there
Yeah.
anything you want to like shill? Anything you want to talk about? Anything you want to link up? Any upcoming events, books, papers, whatever you want to say? Let us know. Shill it. This is your time and chance to get people where you want them.
No, I don't have anything to show, I think. Go give Elixir a try. I hope you enjoyed the conversation. And I think TJ was I think like regardless if you try it or not, I think it will 100% change the way, in some ways, not that's going to change 100%, but it will definitely change the way you think and you reason about software, the way you think. It's going to open up your mind of different ways to think about what is writing resilient software, what is concurrency, right? And how to reason about concurrent systems, like communicating things. And, if you're not familiar with something that is immutable, that is going to change your mind a little bit. So I think like that's the best that can happen. The worst that can happen is that you're going to go to your programming environment and you're not going to like it as much because maybe you see mutability in the same eye that I see. That is just the source of trouble, and things should not be mutable by default. But I hope pretty much that the journey is going to be worth it.
Awesome. That's great. Absolutely fantastic. Just so you know, I'm looking for a new language for 2025, and I think you've sold me. But it's Elixir. I think I can commit
All right.
that my next
That
big
is-
language push is going to be Elixir.
Don't get too excited. When he
Nice.
says 2025, he means January 1 through 7. Like,
Hey, I did
don't
go
get
for
it
this year.
twisted.
I did go for this year, and I did the whole year of Go, writing a distributed game server thingy in it. And so now it's just like I'm going to write games in Elixir that run for NeoVim. So
Now
I'm
we're
ready.
talking. I have Elixir
Yeah.
hooked up to NeoVim. I can show you already. They can change my color scheme.
All right, I
So,
love this.
so yeah, so we just have like chat. I'm going to need your help. We just should not ask Prime about it, right? Because remember,
Smart.
as soon as we ask him about it, he's not going to do it. Okay. So
Smart.
the idea is there, has been planted. We let it simmer. all
So
right?
I kid you
And
not, someone
see
named
you
Spine
2025.
his one of his only comments is Prime should not try Lisp. Try like instead of telling me what to do, tell me what not to do, thus getting me to do it. Already, like the moment he heard that was, don't try Lisp. Whatever you do, don't try Lisp. And it's like, oh hell yeah, I'll try Lisp.
Well, I know you're over, but there is a funny story. So when I started doing Elixir, like I did some false starts, but one of the things that I knew at some point, like based on the whole extensibility thing that we were talking about, is that I wanted to have I want to have like Lisp style macros, okay? But when I started, there were like 2 or 3 Lisps in the Erlang virtual machine. And I was like, look, I'm not going to create a 4th Lisp, right? That doesn't make sense, right? So I was like, well, how can I write a programming language that actually has some syntax, right? It's not like Lisp that there's like no syntax, minimal syntax, that has some syntax, right? But that syntax deconstructs to something obvious that we can write Lisp style macros for. And that's how the Elixir syntax came to be. The Elixir syntax is actually like relatively, like there are few constructs in there and everything boils down like to the same AST, the same representation. And I was very happy. I was very proud. I was like, oh, this is great. I feel it's like something very unique that was not done before. And then it turns out that in the paper from 59 from John McCarty, where he introduces Lisp, he actually introduces as Lisp, which is the symbolic Lisp that we are all used today. But he also introduces M-Lisp because he was like, nobody's going to be writing as Lisp. We need to have some syntax. So he introduced the M-Lisp, right? That translates to that syntax. It just happens that it didn't, the ASP-Lisp is the one that caught on, right? And the thing that I thought was new, yeah, it's as old as Lisp itself. So,
Well, that's just fantastic. So I don't know if, are you familiar with the iLadies paradox?
no.
You don't know? You seriously have not heard about iLadies?
No, I have no idea what you're talking about. I'm even thinking there's going to be a joke in there.
iLadies nuts on your face.
Ah,
Cut.
And that's the show, people.
And cut.
All right. Well, hey, that was
very
fantastic.
good.
I couldn't even
All
handle it.
right.
I was dying on the inside just knowing it was coming.
I wanted you to go speaking of aliens. You
I
forgot
know,
to
I
lead in
saw
with the
that.
speaking of aliens.
But we transitioned from aliens, so I couldn't like go back to aliens.
I know. That's right. We still got them. Flip,
Yeah.
zoom in.
Yeah.
Zoom
Yeah,
in.
fantastic. All right.
All right. Well,
It was a pleasure.
was a great time.
I enjoyed this a lot. Thanks for having me.
thanks for being
And
on.
hopefully I'll see you around.
Honestly, one thing
definitely.
I want to say that's really fantastic is a lot of times people only know you from, say, Twitter, where they only get to see your text or see how you communicate in a written form. And people's perception often is just how they read text. It's not even who you are, it's just how they read text. And so getting the time to see you and meet you, it's just so awesome. I'm so happy I get it. It just makes me so much more pumped to learn Elixir getting to meet you. So appreciate that.
That's very nice. Yeah. All right. And when you just read me on Twitter, it's mostly like the angry voice, right? So that doesn't help much. It's like people are wrong on the internet. So yeah.
That's just
Beautiful.
standard internet
All right.
behavior.
Yeah.
All right.
Hey.
Take care.
Thanks.